As we're getting ready for today's lesson, we're just going to go over really quickly last time's homework because it was on Mathia. Just want to apologize up front. Mr. McShannon and I are still learning this new curriculum. We thought it would be very obvious to you guys where you should start and stop, but apparently, given the number of emails I received over the weekend, was not quite as obvious as we had thought. So basically what ends up happening when you go into Mathia, the lessons in Mathia align directly with our math book. So we had done the composing and decomposing numbers. So when we assigned the module 1, we assumed that was the only ones being assigned. It actually assigned you all of the lessons in module 1. So you guys had a lot more. Those of you that did all 29 workstations, awesome. That means you're basically going to have no math homework on Mathia for the next month and a half. Okay? If you just did the pre-launch protocol and the first 3 lessons, which is what you were supposed to do, then you're right on task. If you went past the first 3, that just means you're ahead of the game for the rest of them. So for tonight's homework on Mathia, just to make it clear, you're only doing the 3 that have to do with prime factorization, LCM, GCF. So it should be basically 4 through 6 workspaces. Shouldn't take you too long. You guys will have your time in seminar tomorrow to do it. So you remember every B day, I highly recommend you utilizing that seminar time to do this. It's a perfect opportunity for you to be able to do so. Hold on. Secondly, if you didn't get in, which we had some people that had login issues, the Mathia computerized homework going to be very lenient on grading. Basically, as long as you get it done before we finish the module, you're going to get full credit if it's done on the computer. Okay? So we understand we're working through a lot of logistical issues. We're going to be as patient with you. Please be as patient with us. Yes, Maverick? That has nothing to do with any of this. Yes? Mr. Beechin is our education technologist. Unfortunately, we are super short in our front office staff right now, so he is pulling a ton of extra work. He's aware of the situation, and he is working on it, which is also part of the reason we're being lenient on this. Just realize it just may be a little while until we get everybody their passwords. I know, like I had a couple of students in my seminar on Friday that I literally spent the entire hour trying to get them on, and I couldn't because it's something that he has to do. But again, we're being very lenient on this, but I do feel, how many of you actually finished the Mathia workspaces? Raise your hand. No, just the first 3. How many of you felt that it was helpful in reinforcing what we had done in class? About half, okay. So some of you, it's a good adjunct. Some of you apparently, at least the first set didn't do as much for you, but let's just stick with it. Again, this is our first year in this new curriculum. Let's give it a good, honest shot. I'll be honest, I like what I'm seeing so far out of this curriculum overall. But as you're going to see in today's lessons, there's some things I don't really agree with. We're still going to show you what the curriculum says, but then I'm going to try to teach you guys a much easier way to do things, okay? So in our first one, everybody should be on page 17. We're basically picking up where we left off last week on Thursday. We're going to have 2 numbers. We've got 54 and 84. First thing I need to do is create a table of prime factors. To do that, you need to do a prime factorization tree. Okay? Once you've done your prime factorization tree, you're going to identify all of the common factors for those 2 numbers. And then of the common factors, which factor is the largest? Okay? So I'm going to give you guys about 5 minutes to do all of that. So you're going to need to do prime factor trees for 54 and 84, find the table of factors, figure out which ones they have in common. I will give you a hint. If they have 2 smaller prime factors in common, you multiply them to be able to get the next larger one. Okay? So I'll give you guys 5 minutes. Go. You finished? No? Most of you didn't finish? Raise your hand if you finished. Okay. Those of you that didn't finish, watch and make sure you're understanding what we're doing. So to find the prime factor trees, all I'm going to do is I start with the number at the top. I draw 2 lines down from it. I pick a pair of factors other than 1, boys, in order to start breaking it down. So, Billy, what'd you use? 6 times 9. Okay, awesome. Then I just check. Can I break 6 down further? Sophia? 2 and 3. Those are both prime, so I circle them. Those branches are now dead. What about the 9? Dan? Awesome. 3 and 3. Those are both prime. Those are both dead. Remember, we talked about using exponents, so I can rewrite this prime factorization as 3 to the 3rd power. We'll start lowest and go larger from there. Yes, Maverick? No, Maverick. There's a lot of different ways to do it. But however you do it, you're going to come down to 2 times 3 to the 3rd power. Okay? Now, let's try 84. Who broke down 84? Raina. Okay, awesome. 2 and 42. 2 is already a prime factor. 42 I can break down as Liam. Good. 2 and 21. 2 is another one, so I circle it. 21 I can break down. 3 and 7. Again, I always go smallest to largest just to make it so it lines up really nice and neatly as I go down. You can write these in any way. You just have to rearrange them at the end so it goes from smallest to largest. So this one now becomes 2 to the 2nd power times 3 times 7. So now that I have the prime factorization, now I can go through and find the common factors. Okay? So what were the common factors? Do they both have a 2? Yes, so that is a common factor. Do they both have a 3? Yes, so that's a common factor. Now, if I have 2 smaller common factors, I can multiply those numbers to get an additional one. So what's 2 times 3? 6. So 6 is also a common factor. Okay? Everybody good so far? Now, of the common factors, which one is the largest? Okay? 6. So this is what we call the greatest common factor, or GCF. Now, they actually asked you to make a table of all the common factors. So if I were really to do this the way they wanted us to, I would also build an entire table with all the common factors for each of the 2 numbers. This is an awful lot of work for something that I can teach you in a very simple way. Would you guys prefer the simple way? Now, here is the key. On the simple way, you have got to understand your 4 key numbers. Does anybody remember them from last week? Callie? Good. Uh-huh. No, you missed the one in the middle. 5. 2, 3, 5, and 7. These are your 4 key numbers, guys. Write these down again if you didn't remember them. These are the ones you're always going to come back to whenever you're doing something like this. That would be your next one, but that would be 5 key numbers, not 4. And 11 actually works pretty easily because I think everybody's familiar. If I have a number like 44, can I divide it by 11? 66. Okay, so that one's kind of intuitive that you realize 11 is there. So once you get to 121, then it's not quite as intuitive. Now, here's why this works, guys. To do this, all I have to do is I write 54 and 84 side by side. And I put a division bar over them. Okay? And I just say, can I divide 54 and 24 by 2? Yes. If I say yes, then I do it. So I say I can divide it by 2. That gives me 27 and 42. If you need to do the math on that separately, please do so. But it should be very simple. You're just doing 1-digit division. Okay? So all I do is I say 2 goes into 5 twice. 1 left over. 2 goes into 14 7 times. 2 goes into 8 4 times. 2 goes into 2 2. That simple. Then I check every level. And here's the other key to this. You have to check your numbers every level. So I look at 27 and 42. Can I divide both of those evenly by 2? No. Can I divide them both by 3? Yes. So then if I say yes, I again add another layer to my cake. So then I put a 3 out here. So then I say 3 times 9 is 27. 3 times 14 is 42. Then I check again. Can I divide 9 and 14 both by 2 evenly? by 3. Not 14. 5. 7. If I say no 4 times, that means I'm done. I don't have any more common factors. Okay? But you have to check all 4 numbers. Once I have that, now it's super easy. Just another note, remember, GCF is to the left. Kind of rhymes. So what I'm doing is my factor is the numbers here. 2 times 3 is, and it's that easy. Greatest common factor. Ironic you should ask that because you did get your highlighters out, because they actually give us the definition right here in the text. Again, one of the things that I really like about our new textbook is they have this vocabulary right here for you. It's also in the back of the book, in the glossary. But for right now, the greatest common factor is the largest factor 2 or more numbers have in common. We'll get to the or more part at the end of the lesson today. Okay? There's another note on the side here with another definition. 2 numbers are relatively prime when the only common factor they have is 1. So it's the only factor that if you've gone through the 2, 3, 5, 7, starting at the first level, and you said no 4 times, that means their greatest common factor is 1. That's the math term for that is they are relatively prime. In other words, they don't share anything in common. Okay? Okay, now I'm going to show you guys another really cool trick. We've talked about the distributive property, right? That was our very first lesson together. We're now going to use the GCF and the distributive property together. So we're going to rewrite each sum using the GCF and the distributive property. The cake method makes this super easy. The cake, what we just did, building on it. I know it was a real long time ago, Destiny. No, it was. It was all the way back here. So all I'm going to do, I use the cake to find my GCF. So I put 56, 42 together. I divide them both by 2. Yes. 6 and 2, they're both even numbers. I can divide them both by 2. I will say, if you don't have a very good grasp on your multiplication facts, cake method is going to be difficult for you. But honestly, any of this math will be difficult for you if you don't know your basics. That being said, in your agendas, if you're struggling, there is a multiplication chart in your agendas. If your basic facts aren't very good, I do recommend opening up and using that chart, guys. So again, this is just single digit division. This should be easy. 2 goes into 5 twice with 1 left over. 2 goes into 16 8 times. 2 goes into 4 twice. 2 goes into 1 2 once. Now I check again. 28 and 21. Can I divide them both by 2? Can't divide 21 by 2, right? Can I divide them both by 3? Can I divide 28 by 3? What's 2 plus 8? 10. I can't divide 10 by 3. Can I divide them both by 5? Can I divide them both by 7? Yes. So now I've said yes. Now is when I add another layer. I add a 7. So 7 goes into 28 4 times, goes into 21 3 times. Anytime I have one of my 4 key numbers on the top line, I just check the other one. If it's not a factor, then I can't take anything else out. Okay? So that tells me that I am done. So my GCF, again, my factor just goes up the side. 2 times 7 is 14. Everybody okay on that? So now here's kind of the cool part and where the cake method really works with distributive property. Because now I know the common factor is 14, and I can use the distributive property to say what would I multiply to get the numbers I started with? Guess what? I would multiply it by 4 and 3, the numbers on my top line. Okay, you look really like either amazed or completely lost. I'm not sure which one it is. Are you okay? Now, here's, again, the cool thing about math. If I wonder, I can always check my answer. So I can use the distributive property, which, guys, using distributive property is literally just those arrows and multiplying it back out. Saying 14 times 4 is 56 plus 14 times 3 is 42. If I got the answer I started with, I know I did it correctly. Is this making sense to you guys? Okay, now I'm going to let you do it by yourself. Use the numbers 54 and 84. Use the cake method and rewrite it using the distributive property. So find the GCF, then rewrite it using distributive property. 5 minutes. Okay, again, and I'm going to use the cake because I think it's way easier for you guys. Once you understand the concept, it's super easy, but it does get down to understanding those 4 numbers and checking them. So I just write 54, 84, side by side. Can I divide them both by 2? Yeah, so I do that. So 2 gives me a 27 and a 42. Okay? Then I check again. Can I divide 27 and 42 by 2? By 3. See how easy this should be, guys? 3 gives me a 9 and a 14. 9 and 14. Can I divide both those by 2? By 3? By 5? By 7? And it literally, I want you to get to the point where it goes that fast. If you've said no 4 times, that means I'm done. They don't have any additional common factors. So my GCF, remember always, guys, GCF is where? That's what it is. Where is it? It's on the left. So I'm multiplying the numbers on the left for my GCF, which equals 6. To rewrite it using distributive property, I take this greatest factor, 6, and I multiply by the sum of the numbers on top. Now I've used the distributive property with the greatest common factor. If you think that's a lot of steps, let's break it down with a prime factorization tree. Because I'll be honest, guys, I don't mind the prime factorization tree, but where that one gets really complex for me is understanding what I need to pull out to find the GCF versus the LCM, which we're going to talk about in just a minute here. Okay? Because we have 2 sets of numbers that we're going to talk about that are all based off of that same basis. LCM and GCF, when I'm looking strictly at the prime factors, gets really complex. If I use the cake, this becomes super easy. Okay, let's go ahead and turn, actually I think it's, turn the page. Going to page 18. We're going to start with our definition on the right here because you need to understand this before we can do anything else. A multiple is the product of a given whole number and another whole number. So if I ask you for the multiples of a number, I'm just saying multiply it by something else. And the numbers I get as I multiply it out are what we call multiples. So we can use a rectangular array to determine multiples and common multiples. So going back to, this is really going back to our first lesson. What we're doing now is we're breaking this rectangle down into a 6 by 8. Does everybody understand the difference between a column and a row? Which way do columns go? I'm seeing 2 different things. Do columns go up and down or left, right? No, columns go up, down. Okay, which way do rows go? Left, right. So columns up, down, rows left, right. Okay? So on our first one, consider the area model for a 6 by 8 is 48. So if I have a 6 by 8 rectangle, I could break it into 6 rows and 8 columns. Does everybody agree with that? Okay? Now, one way to think about the model is to analyze the collection of columns. In other words, say, how many total blocks do I have at this point within this section? So the first column is a 6 by 1, meaning if I added all these up, it would be a total of 6, correct? If I go to the second one, now I have a 6 by 2, so what's my total down at the bottom of this column? Is this making sense? a 6 by 3, I would end up with 18, then. Okay, makes sense? So literally all I did was list the multiples of 6 basically across the bottom. Okay? Now I could also do the multiples of 8 if I looked at it by rows, couldn't I? So if I look at the first row, how many blocks are in the first row? 8. How many if I did all of them in the first 2 rows? The first 3 rows? Then. So all I've done now is build basically a list of all of the multiples of these two numbers. But I have a visual in my rectangle to help me understand what all those multiples mean, right? Okay, so list the first 8 multiples of 6 by labeling each column. We did that. Then think about the areas. So we did all 6 by 8. We did that. So we actually already did 1 and 2. We just did that directly on the picture, right? Okay, pull out your highlighters again. Another side note. The commutative property of multiplication states that for any numbers a and b, the product AB is equal to the product of b times a. In other words, it doesn't matter what order I multiply numbers in, I'm going to get the same answer. Now, where this gets confusing is when we talk about all the different properties in math. So to try to help you on this one, I like to think of commutative kind of like my community or your neighborhood. Now think about this. If I walk out of my house and I take a left and I keep taking lefts all the way around my block, where am I going to end up? At my house. If I go out of my house and I take a right, I keep taking rights, where am I going to end up? So did it matter if I went left or right? No, in my community, if I go either way, it's going to be the same place, right? Yeah. That's just like commutative property. Commutative property, I can do 6 times 8 and get 48, or I can do 8 times 6 and I'll get 48. So commutative property is like my community. It doesn't matter which way I go, I always get back to where I started. Melinda? You can't wait like 6 minutes? Okay, because we're getting ready to go to lunch. Okay? So questions on this part of it. So now let's put this to use. Now 48 is a common multiple. In other words, it's one that they both share. It is not the least common multiple. So we have another one for our highlighters or to mark in your text. The least common multiple is the smallest multiple other than 0 that 2 or more numbers have in common. So that is what we're talking about when we talk about least common multiple. We just want to say, if I write all the multiples of these numbers, where's the first time they meet? Okay? So let's analyze the multiples of 6 and 8 that are labeled on the area model. Identify the least common multiple of 6 and 8. Where's the first number you see both of them? What's the first multiple that they both have? Billy? Not factor, multiple. Look at your rectangles, guy. Yours is on the same page. I had to flip on mine. 24. So Mihana saw that one. The least common multiple of both of them is 24. 24 is the first number that appears in the list of 8 multiples and the list of 6 multiples. Make sense? Okay. So as demonstrated by the rectangular array for the two whole numbers a and b, a common multiple is a times b. However, this number may not be the least common multiple. Sometimes it will be. If they are relatively common, then the least common multiple is going to be the two numbers multiplied together. Who remembers what that relatively common definition meant? Look at your definitions if you don't remember. We just highlighted relatively common on the previous page. What does it mean if two numbers are relatively common? No, go back a page, guys. Tita? relatively prime. So if they're relatively prime, if their greatest common multiple is, greatest common factor is 1, that means we're relatively prime, and the only multiple you're going to see is where I multiply them together. That is going to be the least common multiple. So if they're relatively prime, if they don't share any common factors, then you're going to multiply the two to find it. So I'm going to show you guys the hard way to do this first in order to try to help you understand why this cake method that I'm teaching you is so nice. So we're going to determine the least common multiple of 6 and 9. So I need to list the first 9 multiples of 6. So I'm going to start at 6. Let's list the first 9. So what's my next multiple after 6? 6, then 12, then 18, then 30, then so I don't know if you guys heard it at home, but part of the problem with this is if I make one math error while listing all these multiples, I've now thrown everything off. So if you don't have very solid hold on your basic multiples, this is going to be really difficult for you, okay? And for me, what makes it even worse, if I get into double or triple digit numbers and I'm trying to find the multiples, then it becomes a nightmare because your chances of making an error, a math error, are even greater. Now we're going to list the first 6 multiples of 9. So now I'm going to start at 9. 9, good, 27, 36, okay? Just do the first 6. Because again, if they don't share any common factors, the least common multiple will be where I multiply the two together. But now I can look for the least common multiple of 6 and 9. So in other words, I scrub both lists, and I find the first time that they both meet. Yeah? No? Kelly? 18. Okay? So the LCM, least common multiple, is 18. But here's the problem. 54 is a common multiple. 36 is also a common multiple. So if you notice the 36, you can fixate in on that before you get all the way back and see the 18. So they actually have 3 multiples together between 0 and 54. They have common multiples at 18, 36, and 54. And see where this starts to get difficult? Okay? Especially if I'm having to make all of these lists. Now, do you want to see the easy way to do this? Okay? It does come back to our cake and making sure we are very careful while we do it. So if I have 6 and 9, can I divide them both by 2? No. Can I divide them both by 3? Yes. So I put a 3 on the side. That gives me a 2 and a 3. I'll give you a hint. If I've got a common, one of my 4 key numbers is on top, unless the other one's a multiple of it, I'm done. So my GCF for these two numbers is 3. See how easy that is to find? Okay, and we'll hit the LCM when you guys... Okay, let's finish this off. So here is the linkage for the cake method between finding the GCF and the LCM. Again, until you get this down, I'd keep making this note. GCF is on the left. So the left side gives me my factor, the GCF, which is another way to think of it and help you remember. The factor is the small part, right? The multiple is the big one. So for the multiple, we're actually going to multiply everything on the outside. So I just multiply. What's 3 times 2? 6 times 3? My LCM is 18. And this, honestly, guys, is the biggest reason I far prefer the cake method. Number 1, I do think it's easier, but number 2, I get both the GCF and the LCM with one set of work, no questions about how to find them. Okay? You can find the GCF and LCM using prime factorization. The problem is, to find the GCF, I have to pull out the smallest thing that they both have in common. To find the LCM, I take out the biggest thing that they have, whether it's in common or not. So it gets really confusing when you're using prime factorization to find GCF and LCM. You have to be really good at your math to understand what numbers you're using. Use the cake method, it's easy. It's literally all laid out for you. The GCF, the greatest common factor, is on the left. The least common multiple, I literally just multiply every number on the outside once I get to the last layer. I'm not going to be able to make it any easier than that for you guys. So, now that I've given you an example, I want you to find the LCM of 7 and 8. 2 minutes. Okay, so if we're using the cake, this is super easy. 7 and 8, can I divide them both by 2? By 3? By 5? By 7? If I've said no 4 times, what's their greatest common multiple? Greatest common factor? 1, which we call relatively prime. If they are relatively prime, I just multiply the 2 numbers. 7 times 8 is 56. Remember, for my multiple, I'm multiplying everything on the outside. 1 times 7 is 7, 7 times 8 is 56. You guys see how easy this can be? Are you going to be able to differentiate between the greatest common factor and the least common multiple using it? I hope so. So, using prime factorization, how can you determine whether the least common multiple of 2 numbers is the product of 2 numbers or is less than the product of 2 numbers? This is what the kind of stuff where I'm saying it gets really confusing if you're not using the cake method. Because if I've got the prime factorization, and I'll give you the answer. So if I use prime factorization, that's where I'm going to have the whole list of all their prime ones. How can you determine whether the least common multiple of 2 numbers is the product of the 2 numbers or is less than the product of the 2 numbers? It is basically, if they don't have any in common, then it's going to be the product of the 2 numbers. So if they have no common factors, the LCM is the product of the 2 numbers. Again, if I write it on the board, you should be writing it in your books, guys. So I'll give you guys a second to write that down. But that is the biggest thing. If I'm doing it by prime factorization, if I come down to the end and I don't have any common factors, then the LCM is just the 2 numbers multiplied by each other. So I'm going to do this while you guys are doing this. If I were to do a factor tree for 7, it's just 1 and 7 because that's a prime number, right? So my prime factorization would have been 1 times 7. If I did 8, then I have 2, 4, 2, 2. So this one is 2 to the 3rd power. You can see I don't have any common factors between those 2. That means the LCM is just multiplying those 2 numbers together. Does that make sense so far? S numbers. Okay. Turn the page. Now, let's take a look at this. Suppose I want to determine the LCM of 56 and 42 without drawing an area model. In other words, I don't want to draw one of those big rectangles of 56 and 42. Can I find another way? Yes, I just taught it to you. So, practice. Do you guys need another example for the cake, or do you want to try it on your own yet? You're going to have 3 chances to try it on your own on the next page. Okay, so I'll give you one more example because I actually want you to find both the GCF and the LCM for each of these 4 sets of numbers. So I'll do number 1 with you, and then I'm going to let you guys do the next 3 by yourself. So again, 12 and 10, I just write them side by side. Can I divide them both by 2? If I say yes, then I do it. I put a 2 here, and then I actually divide these numbers by this. So 12 divided by 2 gives me 6. 10 divided by 2 gives me 5. 10 divided 6 and 5 by 2. By 3. I'm already at 5, so I know I can't go any further. So that means that my GCF is 2, because that's the only number on the left. My LCM, and here's another kind of cool thing about this. The commutative property, remember I can go left or right out of my house, I get the same answer. I can do this in any order I want to. So I'm going to make the math easy. What's 2 times 5? 10 times 6? Is this hard? Okay, now we'll see if it's hard. Here's your chance to do it by yourself. You have 3 sets of numbers. I want you to find the GCF and the LCM for all 3 sets. Okay, the first one should have been pretty easy. 9, 15. Can I divide them both by 2? By 3. 3 becomes a 3 and a 5. Guys, I'll give you a hint. If I got 2 of my key numbers on the top, do I have to check? No, because I know I'm already done. So my GCF is 3. It's just what's on the left. My LCM, I'm multiplying everything on the outside. 9 times 5 is 45. Our next set, 9, 10. Can I divide them both by 2? By 3? By 5? By 7? No, so that means it's a 1. So what was the math term we just learned if their greatest common factor is 1? They're considered to be awesome, well done. Those are relatively prime numbers, meaning my GCF is 1. My LCM, I just multiply the 2 numbers, is 90. Our third set, 5 and 9. I divide them both by 2. By 3? By 5? You guys start to see how fast this should go? If you know your 4 key numbers, this stuff is so easy. 1 gives me a 5 and a 9. My GCF is 1. My LCM is, we're multiplying, not adding, 45. So multiply everything on the outside for LCM. Questions on this? Is it making sense to you? Yes. Do you understand how these numbers all go together, the factors and the multiples? Okay. Turn the page. Let's bring it back around now. So now we're going to put it all together, going all the way back to our previous lesson. Okay? So we've composed and decomposed numbers using factors and multiples. Now, we're going to consider the sum 36 and 24. We're going to express the sum as many ways as possible as the product using distributive property A times the quantity B plus C. So just to reaffirm how we do this, all I'm going to do is 36, 24. What goes into both? Can I divide them both by 2? Yes. 2 gives me 18 and 12. Can I divide those both by 2? Yes. Gives me another layer. Gives me a 9 and a 6. Can I divide both those by 2? By 3? Yep, so I do. 3 gives me a 3 and a 2. Those are 2 of my key numbers. So, my GCF, what do I do? How do I find my GCF? Michael? Multiply all of them on the left. So 2 times 2 is 4 times 3? 12. My LCM, I multiply everything on the outside. So now I've got, and you can do this any order you want to. Personally, what I would do is break it down into 2 numbers. 3 times 3 is 9. 2 times 2 times 2. 8 times 9. If you don't understand what I did, you can do that in any order you want to. So I could have gone 2 times 2 is 4. 4 times 3 is 12. 12 times 3, 36. 36 times 2, 72. Or I could have just done 9 times 8. I prefer the easier math. But that's the beauty of the commutative property of multiplication. I can do it in any order I want to. I'll still get back to my house. Make sense? Now, here's the other cool part and where this builds into what we did with distributive property. So if I multiplied on the side, I got 12. So I can rewrite this using the distributive property as 12. And they've already given me what I need on the top. This goes on the inside. 3 plus 2. See how the cake lays all of this out for you? Lauren, do you see it? And if you want to double check yourself, again, part of the beauty of math, I can always make sure I'm right. I actually use the distributive property to see if I get the right numbers. 12 times 3 gives me 36. I have a plus, I put a plus. 12 times 2. Is that where I started? So I got back where I needed to. I was able to break them down, decompose, and put them back together. Pretty cool stuff, right? Why not, Melinda? Okay. Can you always determine the greatest common factor of any two numbers? Yeah, right? Yes. And I'll be honest, check your 4 key numbers. Your 4 key numbers. That is your whole ability to succeed. Okay? When the greatest common factor of two numbers is 1, what can you say about the numbers? Anybody remember the math term we just learned about that? No. If the GCF is 1, what's the math term we use for that? Kelly? You had your hand up. Now you dropped it. Brandon? Thank you. They are relatively prime. How did you not know this question? It's literally on the board and in your book. Okay. Now, to find the GCF of LCM of two relatively prime numbers, what do? I just multiply them. So multiply them for the LCM. So if my GCF is 1, the LCM I find just by multiplying the numbers. Can you always determine the least common multiple of any two numbers? Yes. Use your 4 key numbers. If you're using the 4 key numbers, you can find the least common multiple of any. When the least common multiple of two numbers is the product of those numbers, what can you say about those two numbers? I actually just gave you the answer. Oh, I can slow down. Yeah. When the least common multiple of two numbers is the product of those numbers, what can you say about the two numbers? Thank you. Literally, I just put it right here, guys. They're relatively prime. Multiply for the LCM. So if I'm multiplying for the LCM, that means they're relatively prime. Their greatest common factor is 1. Now, I'll be honest with you. Most of the time on standardized testing, they don't give you relatively prime numbers because they want to see that you can actually break them down. So it will actually be very uncommon for you in any type of testing situation to be given relatively prime numbers and do GCF LCM. Because if your GCF is 1, then you're just multiplying them for the LCM. Yes, you have tests. Any questions on this page? Michael, you should have had something written on everything there. For any of you that have blank spots on this page at this point, you're wrong. I've written down the answers. You should have written them down in your book. What was B? Oh, how can I use the factors to determine whether you listed all the possibles? Basically, what that's saying is I could have done 2 times, I could have done this as 2 times 18 plus 12. I could have done 4 times 9 plus 6. And then I could have done the one that we did, which was 12 times those. I also could have done actually 6. And then that one would have been a little more interesting, times 6 plus 4. So basically what it's saying is I could use those factors in any combination to find an additional set that I could have used to use the distributive property. That's all that one was saying. That's why I skipped over it. Because to me that gets a little confusing. We're honestly focused on GCF and LCM, not the other factors. Exactly. Thank you, Melinda, for putting that in such great words. Any questions on any of this? Copy from a neighbor. Okay, here's your homework. So go ahead and tear this page out. This is 25 and 26. For those of you that worked ahead on the Mathia workspaces, you're already done with the Mathia part. Now, we do have a slight disadvantage, as I think it was Maverick pointed out. We have a field trip tomorrow, so you won't have seminar to do this. Although, honestly, we'll probably be coming back about 1:30, so you should have about a half hour in seminar tomorrow to work on this. But your actual work here, let's go through this. Your journal entry. The LCM of two numbers is always, sometimes, or never the product of the two numbers. So think about everything we just went through. Write your journal entry as to which one that is. Create a factor tree and write the prime factorization. So this one, Sophia, you're supposed to be listening right now. I'm going over your homework with you. This one, Maverick, did I tell you to pack up? You should be sitting and listening. So on this one, you do need your factor trees for the prime factorization for these. The next part, you have two options on number 2, okay? You can come straight to part D if you use the cake. And what I just taught you, if you use that, go straight to D. If you would rather go through all of these steps, you may do that, and then you'll eventually get here. But if you want to use the cake method, go straight to D and find the GCF. Okay? Turn the page. There we go. On this side, same thing. So part C, you can do A and B, or if you do cake method, cake only do C. Whoa, hello. If you use cake, only do C. Okay? So if you do the cake method, you'll basically have 2 problems on the homework. If you want to use what they say, then you can break all those down the way they say. Now, for this part, for each of the pair of numbers, determine the least common multiple and at least one other common multiple. So you're finding the LCM, but I also want you to find the GCF, because it's all one step anyway. So find the GCF and LCM for all 3 sets of numbers. Billy, question? Not if you use the cake method. If you use the cake method, you only have to do D and C. If you don't use the cake method, then you're going to have to walk through all those different steps. The cake method. If you're using the cake, you skip A, B, and C. You just go straight to D. That's it. Now, if any of you want to do the optional, I do want to show this to you because I think it's pretty cool. So we haven't covered how to do 3 numbers. 3 numbers, there's an extra step in it, okay? So I'm going to just do number 4 for you. So all I do is I start by listing all 3 numbers underneath my bar. And I say, what can I divide all 3 of them by? Can I divide all 3 by 2? By 3? Yes, so I put a 3 out here. That gives me a 3, a 5, and a 6. Then I check again. Can I divide all of them by 2? By 3? By 5? I know I'm done because that's it. Here's where it gets different. If I have 3 numbers, I've now found my GCF. My GCF is just 3. But now I'm going to look and see, do I have any 2 numbers that have a common factor? So, do I have 2 numbers I can divide by 2? No, those are both odd. I can only do 6. Do I have 2 that I can divide by 3? Yes. So I'll do one more layer here with a 3, and then I divide what I can. If I can't divide it by 3, I just bring it up. So 3 divided by 3 is 1. Can't do the 5, so I bring it up. 6 is a 2. So I'm now done. Now my LCM is still the same thing. So my GCF is just the 3, not 9 like normal, because I've got 3 numbers. But my LCM, I do 5 times 2 is 10. 10 times 1, 10 times 9, 90. My LCM is 90. So that's the only change between 2 and 3 numbers, is this glass ceiling, where I go from checking all 3 of them to checking 2 of them. Maverick. Oh, is that why you raised your hand? Wow, that's so weird. Yeah, okay. We'll worry about Thursdays when we get to Thursday. Any other questions on your homework? Yes, ma'am. Matthew, it's just the next 3 sets. So I wrote them on the backboard. So it's a prime factorization, determining the LCM and GCF, and using GCF to rewrite the sums. So it's basically numbers 4, the workstations 4 through 6. Okay? Any other questions? And again, we're being really lenient on the Matthew stuff, so just do it when you can. Thanks, guys. Have a great day.